Yeah, so my name's Eric Gallandt. I'm a professor of weed ecology and management at the University of Maine. For those of you that haven't been on the other side of the Mississippi, that is the outline of the state of Maine. It's a developing state in the far northeastern part of the United States. The green is mostly trees and moose and things like that. The green dots represent organic farmers, certified organic farms, and that's my primary clientele. I've been working with this group of stakeholders for almost 20 years. Some of them are quite well known. Anybody recognize that guy? Elliot Coleman. So organic farmers, despite the fact that I've been working to try to help them better manage weeds for almost 20 years, weeds remain their foremost production problem. And although they will often or always cite crop rotation and cover cropping as foundational strategies, when you look at the direct weed control, they turn to cultivation, so physical weed control. Very typical row crop cultivator there, and that's a very typical result, that you see your crop, but you still have this problem of weeds in the crop row. So physical weed control, there's a lot of great things about it, but there's also a lot of problems. Okay, if you are going to sell a really good herbicide, what percentage of the weeds would it have to kill in order to go to market? 98% of the weeds, and it would have to do that all the time. Otherwise, you would have grouchy farmers coming back. If you look at cultivation, though, cultivation rarely approaches high 90%. Cultivation efficacy is low, and it's really variable. I'll show you that. It's also, the efficacy is density independent, and what that means is that you kill 60% of the weeds, and if you're starting off with a low number of weeds, 60% is like, ooh, that's awesome, only 40% survive. But if you start off with a lot of weeds, you still only kill 60%. So the density of survivors ends up being then proportional to your starting density. So that's another foundational problem. That's also true for most herbicides, but and so consequently you end up seeing, due to this low and variable efficacy, is that on many organic farms we have an increasing weed seed bank. So your weed problem gets worse every year, or at least stays the same. So I want to go into this a little bit more depth. So when I talk about efficacy, I'm talking about the proportion of weeds that are killed. And so we measure this by hiring loads of undergraduate students. We go out into a cornfield and we mark a spot, we put down a quadrat, we count the number of weeds, we come through and cultivate. So we have, we count the number of weeds, before we cultivate, come back, count again, and you can see in this case, we killed 50% of the weeds with that pass of the cultivator, okay? So it's, lots of effort to do this, but it's the way to get good detailed measurements on how effective our cultivation is. Here's an example of a data set. This is from a 3-acre field of corn, where we went out and we randomly picked, this pointer is terrible, 139 locations where we did those sorts of measurements and measured efficacy. And in this case, we were using that row crop cultivator you saw, so a typical old International with S-tines and sweeps. And we were actually using a surrogate weed, in this case, condiment mustard. So the weed species is all the same, and it was all at the same size. So we're trying to simplify the system. And still, dead level, flat field, look at what the efficacy was. It ranged from 0 to 100% with a mean of 67%. All right, so it's really variable. And we're only, people have not spent a lot of time since the advent of the dawn of the herbicide age studying mechanisms of physical weed control. So the sources of this variability are not really well known, but it's a problem. Density independent efficacy. That basically means that 67% average mortality I just showed you, if you start off with, say, this field of crabgrass and you kill 67%, you end up with 33% surviving. And so then you have to look at that situation and go, well, is that okay or is that not okay? And so What most farmers do, and the simplest solution, and if you don't want to complicate your life at all, I'll finish up really quickly and you can get out of here and into another session, is that you just cultivate again, and you keep cultivating again, killing 67% until you look out there and you're like, okay, that looks good enough, and then you stop. So that's the cultivating more solution. And I'm not gonna judge, but for many farmers, cultivating more simply doesn't end up panning out, and you end up with this increasing number of surviving weeds. When the weeds survive, they have a lot of weed seed rain. The seed rain creates a seed bank, which are the seeds on and in the soil. And this is my friend Mark Guzzi, very successful organic farmer, and he knows that I'm showing you this photo. We went out and measured at, I think, at 29 locations across his farm, take soil samples, bring them into the greenhouse, look at the germinable weed seed bank, and he wins the award for the highest number we've ever measured. That's close to 50,000 germinable seeds per square meter to a depth of 10 centimeters. That's a lot, okay? I think we call that a shit ton. So what are the solutions? Like I said, cultivate more. So you just keep going out there and you realize, okay, 67%, that kind of sucks, but at least it's simple. You know what you have to do. So you could also try to cultivate better, and I want to talk about that in more detail. And then if you want things to get better over time, ultimately it's not going to be solved just by cultivation alone. You have to start with fewer weeds, all right? So there, if you want to just keep it simple, cultivate more, you can head on out to the next session, because I'm not going to talk about that. That's super easy. Now, cultivating better. How do you cultivate better? So this efficacy, this proportion of weeds killed, is going to be something that a lot of people call, oh, there's an art to cultivating, right? And art is just a euphemism for like, oh, it's super complicated and I don't want to deal with all the parts. Because we know that there are some of these parts that we can deal with, all right? We know that the choice of tool can affect your efficacy, the proportion of weeds killed, and the design of the tool, adjustment, speed. Your weed, we know some species are easier to kill than others, and we all know that bigger weeds are harder to kill than smaller weeds. Crop selectivity is important. A whole bunch of site characteristics. I only have time today to really talk about one, but I want to talk about this aspect of it, the tool and the design, because at least when I go to the farms that I work on in Maine and northern New England, a lot of people are using the same old tools like that old International cultivator that I showed you. And it turns out there's a lot of really great stuff out there. We got a recent grant, and fortunately when we talked about trying to do some enhanced cultivation, I talked to Jean-Paul, and I had an order for a cultivator, and I tossed it, and I went and talked to somebody that Jean-Paul knew in the Netherlands, a guy named Koos Havelier, and told him what we wanted to do, and he basically designed this cultivator for us. It's on a 3-point hitch, it's got a rack and pinion steering so that you can guide it, and basically it has a set of tools that we would say are stacked together. So rather than just that old IH design that your grandfather used with the Danish Hestein and the sweeps, here there are some sweeps. So right here would be the crop row. So there's another crop row up there. It's a 2-row unit. So you can see here some sweeps, side knives, and then some torsion weeders, and then some finger weeders, and then a tine rake, all of them quite adjustable. And when we got this thing, we were like thrilled, because we're like, oh my gosh, look at all these tools. Can you imagine trying to be a small weed seedling, surviving that gauntlet of physical mechanisms of action? And my graduate student, Brian Brown, was like, oh, and this is great because we can test these in all different orders. So he did experiments with torsion, tine, sweep. You know how graduate students do. It's awesome that they're doing that stuff for us. And so, imagine yourself now as a seedling in that intra-row area of corn. That's kind of sucky environment, right? I mean, basically we got rid of those sweeps, and this was, I won't go into that. So we focused on this intra-row zone. That's where the money is. That's the most difficult area to control the weeds. And we defined it as this 10-centimeter zone. And so we would do a lot of these pre and post efficacy measurements. And the results were really cool, and we were very excited to see that as you went from just a single tool on that machine to adding 2 tools to adding 3 tools, this stacking of tools tended to increase your mean efficacy, and you can see here in the 3 tools, it reduced the variability. Moreover, when we actually selected out the design of the torsion finger tine, that's that group of points right up there at the top. And we're like, whoa, this is so cool. We have found this great effect of stacking tools, and we publish a paper with stacking in it, so we're going to try to like trademark it and stuff. So anytime you guys say it, you get royalties and all that. Anyways, I showed these results to Koos Havelier in the Netherlands, and we're like, check this out, this is so cool. Look at what your machine does. And he's like, yeah, that's how we designed it. And sure enough, that's how it came out of the box. Torsion finger tine. And so, yeah, he was less excited about the results than we were, but yeah, okay. So when you separate out some of these effects, another really important result was that if you look at these individual mechanisms, the torsion, for example, with about 40% weed control, the finger weeder down here at 30%, the tine weeder. If you add these together and you put them together, the expected result would be here, and we actually observed this, which is a statistical evidence of synergy. So we're getting beyond an additive effect. So it is this idea that by combining a couple of physical mechanisms, it is more than just the simple additivity, okay? And we think that that's pretty exciting. Brian did this over increasing soil moisture, and the synergy held true there. Over increasing weed sizes, it held, and over increasing tractor speeds. Okay, so it seems all of those things would reduce the overall efficacy, but this advantage of stacking held true across those challenging environments. We still have to do more work on selectivity. So this is not the end of this sort of research, but I'm hoping it's just the beginning of sort of a new effort to dig much deeper into physical weed control mechanisms. I'll just pause for just a second. Any questions on that, on the stacking stuff? You didn't know I was going to give you time for questions, but you're good? I just wanted to also note that just for any of you that are much larger scale farmers, and you look at our small test rig there with a graduate student sitting on the back of it, it's very easy right now to scale this up to any kind of scale you want, okay? This is a side shift unit from Garford in the UK, uses cameras to figure out where your crop rows are, sends a signal to hydraulic unit between your cultivator and the tractor so that you can adjust even closer to the crop row and maintain working rates of 5-6 miles per hour, okay? So this is ready, off-the-shelf kind of stuff. The side shift unit you can buy for, I think, $40,000 for their smallest one. All right. So that's cultivating better. Yes?
Yeah, so any kind of row crop, basically, or any kind of row crop?
Well, like I say, so the question is, will this work for any kind of row crop? My working hypothesis now is that this is a principle, that you start adding on these different physical ways of disturbing the soil, and you're uprooting, and then you've got a tine that's coming through and shaking soil off of a small plantlet. That's going to work whether you're using maybe a different set of tines in a cereal crop. I don't know. We need to do that work, but it's pretty promising. All right, so that's cultivating better. And I think there's more we can do there. Now I want to finish up with what has really been the core of my research for quite a number of years, and that is related to starting with fewer weeds. And when you start talking about the idea of starting with fewer weeds, you have to think about the weed seed bank. And so the weed seed bank are the weed seeds that are on the soil surface and in the soil. And the bank metaphor is quite apt in that ultimately we want to maximize the debiting of this bank. We want to draw from the seed bank. We want to minimize the credits, okay? And the strategies to do this are something that a colleague of mine, Matt Liebman, and I defined back in '97 as a multiple stress approach, many little hammers. Anybody ever heard of using many little hammers to manage weeds? Matt did all the real brainy work on that chapter, but I came up with the title. So the general concept is one of, okay, it's not that we're going to ignore cultivation, or if you're using herbicides, ignore herbicides. It's just that rather than putting all of your weed management focus on seedlings, we're going to de-emphasize that, and we're going to think about all these other wonderful ecological processes like crop competition, preempting seed rain so that you don't have any deposits to your seed bank, improving predation or seed decay. You know, this is sort of the realm of ecologists. Ecologists just love this stuff. But I will say that some practical farmers would look at this and they'd be like, okay, I like that idea, but why do I want to make my life more complicated? And that's the people that solve their problems just by cultivating more, all right? So, but if you don't mind adding a bit of complexity and you start thinking about, well, how can I do some of these things based on my knowledge of the biology of my weeds and get multiple benefits? And so this is where crop rotations or cover cropping done strategically can impact many of these sorts of processes. There are a whole bunch of hammers, and there's a bunch that affect weed crop competition. I'm not going to talk about those. We already did cultivation affecting seedlings. I'm going to finish up today with a few examples from our work and others related to controlling weed seeds. And I'm not going to get to the predation. I had to cut that out. But I'm going to talk about these. And these are in my own order for the most impactful. If you can preempt seed rain, that is going to have the most dramatic effect on your seed bank. Next, once you've failed to preempt seed rain, if you do have seeds in the soil, the most effective way to get them out of the soil is to get them to germinate. We've done other things, and I had hoped for a long time that it would be microbial decay and stuff like that. It's not. It's germination. And then thirdly, if you have an abundant seed bank and you want to reduce the weed pressure prior to a crop, solarization and tarping are really promising strategies. And then lastly, I'm not going to have a chance to talk about this, but if you do have seed rain, you are much better off maintaining those weed seeds at the soil surface where animals can eat them. It's one of these conflicts, like from NRCS, they would like you to, put in a fall cover crop to protect the soil from erosion, which is awesome. But from the weed standpoint, that's exactly what they want you to do, right? The weed seed rain falls, and then you come in and till the field and plant a cover crop. You've just buried all those seeds, and predation rates plummet as soon as you've buried those seeds. That's all I'm talking about, predation. All right, so starting with preempting seed rain, I'll just give you just a couple of quick examples here, and this was something we did kind of after a bit of an argument. This is Mark Guzzi again with the the University of Maine record weed seed bank. And we went out and in a couple of spots on his farm basically helped him clean out some areas and kept them weed free for a summer. His workers are walking by wondering what the crazy university people are up to now. But you could see by preempting seed rain on this vegetable farm for one season, you could walk by and see those parts of his farm for 2 years. So 1 year of preventing seed rain, and you could see a reduction in weed pressure for a couple of years. We measured it by doing those seed bank analyses, here you can see 45% reduction in the germinable seed bank in this one case, and 93% reduction in another case. The question you might ask is, well, how can this work? You weed people have told us that weeds produce billions of seeds and they last forever in the soil, right? Okay, they don't. I'm sorry we told you those stories. They don't last forever. Some of the seeds, a few of the seeds, a very small number, like I used to tell the story about the chenopodium in the archaeological jug they found that's 2,000 years old, you know? And people, you know, remember that. Well, the fact is that most of the seeds, you know, are gone within a year or so. The half-life for most of our important weeds are a year or less, okay? So this is a typical decay curve. It's varying from species, so some species are more long-lived, some are more short-lived, but generally speaking, the time to 50% reduction is about a year or less. And this is true for lamb's quarters, pigweed, all your annual grasses. And so what this means is that if you don't have seed rain for 1 year, you've just experienced a halving of your germinable seed bank. Do it again, you've halved again, and suddenly you're like, whoa, there's fewer weeds out there. All right, now there are some extremely long-lived weeds, and if you have some of those, sorry, just cultivate more. Okay, so how do you do this? Yeah, okay, again, if you're you know, a corn and soybean farmer, this is going to be really challenging for you. But as you start adding diversity, shorter season vegetable crops or shorter season cover crops, something where you're going to terminate a crop before the weeds reproduce and have seed and produce seed rain, you can preempt seed rain. So think strategically, how can I do that? All right, so that's preempting seed rain, and hopefully now you all realize that weed seeds don't last forever. A few do, but most don't. All right, so next, once you've got weeds in your seed bank, what do you do to get rid of them? And the most effective way to deplete it is to encourage the seeds to germinate, to get them to break dormancy, shallow tillage, fallowing operations, at the time when the weeds want to germinate. And this has been popularized by probably the two most articulate, ecologically based weed managers I've ever met, Eric and Ann Nordell. If you haven't watched their videos and you're interested in managing the seed bank, this is kind of the first reference that you want to go through. But basically, they decided to manage for very, very low weed pressure on their farms because they didn't want to hire a lot of help. So they came up with a rotation that alternated vegetables with cover crops and fallow. So this would be one field going from veggies in 1 year to cover crops and fallow, veggies, cover crops, fallow. Over time, they would change the time when the fallowing was done or change the cover cropping because the shallow disturbance that they were doing was both encouraging weeds to break dormancy, getting them to germinate, then they could kill them with another tillage event, thereby germinating the weeds out of the seed bank. And then all of those were done, they were all short enough that there was no weed seed. So both depleting the seed bank and preempting seed rain within a season. So they're getting a half-life reduction and depletion. Here's what it ends up looking like. Here's a couple. This is Mark Guzzi's farm. So Dixmont, this is not the record-winning soil sample, but these would be soil samples where we then put them in a greenhouse flat, allow them to germinate. So it's the germinable weed seed bank or weed pressure you're looking at. And this is another farm in Durham, Maine. And then this is one of the typical fields from Eric and Ann Nordell's place. I just give you a close-up. This is the weediest one we found, and if you're in the front, you can see what their major weed was. There was some volunteer tomatoes. So the key thing to that is that they know as much about weed biology and ecological management as I do, and they apply those cover crops and the timing of their disturbance really strategically. So when these disturbance events occur is really important. If this is so this would be a time series, and this would be, let's say that this is hairy Gallansoga or I don't know, crabgrass or something, but it's going to have a certain germination and emergence periodicity, right? So, imagine this is your weed doing tillage out in here or doing tillage out in here. You're just moving those seeds around in the soil. You're not going to encourage them to germinate. But when they want to wake up, or however you want to put it, you have some shallow disturbance. You encourage high rates of germination. You let them grow because at that point they're just a green manure for you, but you have tillage here that preempts their seed rain. So you drive this part of your dynamics and then you prevent your seed rain. So that's how they do that. And anybody can do it. It's not that they have some sort of art. All right, another example that I think is really encouraging is the use of tarps and solarization. So you've got a really weedy situation and you want to drive down the weed pressure before you plant a sensitive crop, for example. I'll show you just a quick example. We did a number of on-farm trials. My graduate student Sonia did. We did some clear plastic. So with clear plastic, it's called solarization. Basically, we wanted to try to create like a greenhouse effect on the soil, drive a lot more germination so that then when we tilled and got ready to plant carrots or onions, we had a highly depleted, stale seed bed, right? Well, you could also do the same sort of strategy with silage tarps or black plastic or something. This is what it ended up looking like after she pulled the tarps. We thought that there would be, more weeds under there that we could then kill with tillage. It turns out that there was a lot of weeds that came up, but then it was so hot that they died. All right, so you drive germination, but then the conditions are such that you kill the small seedlings. When you look at the temperatures, it's really quite impressive. So up to, I think she had a couple that were up in this 115, 120 degrees Fahrenheit at a 2-inch depth. So that's going to be quite a bit warmer than that at the top centimeter or so, and that's lethal for quite a number of weed seeds. I will say we did one trial where the most abundant species was purslane, though, and purslane, it's a tropical, right, Fabian? Anyways, it has very high thermal tolerance, so we ended up with a complete sod of purslane. So if you can convince people that it's like this great high linoleic acid plant to eat or something, it's a good strategy. So anyways, this is really quite promising. Lots of people doing this, especially all of the young farmers that have read Jean Martin's book. People are using tarps to try to drive down the germinable seed bank before planting into it. And lots of good reasons to do that. At least on smaller scales. The last things I wanted to mention to sort of wrap this up is that I've tried to give you an outline of some of these different strategies, both for improved physical weed control, but then this host of these other ecological approaches to managing weeds. There are farmers using all of these approaches that you would consider to be successful and happy farmers, all right? We went out and interviewed 23 organic farmers in northern New England in 2010, and they were all over the board but they really did sort of fall into two major groups, kind of the cultivators who were practicing like the critical weed-free period, just beat back the weeds until the crop has enough of a head start, and then let the crop go, right? Come on, some of you are in here right now. How many people do that? I'm not judging. That's a very effective way. He's a really happy guy, making lots of money. The only downside of that is that you have the seed rain, and you're guaranteed to have to do the same thing in future years. Some other farmers are more seed focused, all right? When you looked at the weed seed banks on these 23 farms, it ranged from a low of 2,500 up to 25,000 germinable seeds per square meter, okay? So it's all over the board. In terms of, if you want to orient yourself, low would be below this line. So the Nordells were somewhere in like 1,000 or 500 per square meter, some even less than that. So we have just a couple of farmers that are really low in their seed bank. Lots in this middle area, but then a pretty large group that just have a really abundant seed bank. Again, not passing any judgment. There's all sorts of ways to do this. It's kind of knowing what you have and what you want to have. And I guess my point here today has been to show you that, if you are out in here and you want to get here, it is indeed possible to do that. The foundational approach that I think is one of combining these strategies, in particular this idea of improved cultivation and seed bank management. So I spent 15 years really focused on many little hammers and multiple stresses and soil improving cover crop strategies to do this. And the ecology just gets overwhelmed by really crappy cultivation and high levels of seedling survival. It just can't deal with it. But I'm convinced, and this is my new working hypothesis that I'm spending the next 5 years doing, that if you get this level of seedling control really high and reliable, you're going to have fewer surviving weeds and less seed rain, and it's going to make your seed bank management more effective. So you're going to then start with fewer seedlings next year, and you're going to end up with a positive feedback loop where your population growth rate is declining over time. And so that's the things that we're working on. One caveat to that is that prior to me completing this work, I am a little worried that I might be outsourced, because the robots are coming, and the robots solve almost all of the problems I outlined for you. Even if Turtel's efficacy is 67%, who gives a rip? It's ultimately patient. It'll just be out there killing 67% as long as it needs to. It doesn't compact the soil. It's not oxidizing soil organic matter. This is available on Kickstarter right now. It's not ready for prime time. This is for home gardeners, but it went from an idea like that to a Kickstarter in 2 years. In comparison, we haven't had a new herbicide mode of action for 30 years. So if you wanted to put your money on where some of the real solutions are going to come from, I'm not saying Turtel in particular, but the idea of robots, either large, complicated ones or small, disparate, swarming ones, or whatever the engineering solutions are going to be, but that technology is moving really quickly. And so I'm sort of looking at the time horizon between my retirement and when the robots take over. So I want to acknowledge all these great folks that really did this work and have really impacted my way of thinking about weeds. We do have some of this practical stuff up on our website, and a really cool website or YouTube channel.